Hello friends and welcome to Notebook. This lesson is going to be about the numbers which follow usual mathematical rules in their operations and obey the laws of the land. These are called rational numbers as opposed to some rogue numbers called irrational numbers. In this class, you will learn to tackle rational numbers so that you are better equipped intellectually to tackle irrational numbers in your higher classes. Do you know what the word ration means? It means a fixed portion of allowance from an entire provision, especially to soldiers in a war front. Do you see that here we are vaguely referring to parts of a whole? Isn't that the same meaning as a fraction? Yes, it is. So both ration and rational numbers are derived from ratios, which are nothing but fractions. Now, if there are 100 kgs of ration and 24 soldiers, it is reasonable to expect that each soldier will get 100 divided by 24 kgs of ration, which is a ratio of 100:24 or fraction 100 by 24. 100 by 24 gives a quotient 4 and remainder 4, isn't it? Hence, similar to capital W for whole numbers and capital N for natural numbers, we denote the set of rational numbers as capital Q from the word quotient. Suppose all the soldiers are dead in the war and the provision of 100 kgs are still sent to the war front. So 100 kgs is to be divided amongst no one. It would be meaningful to send the provision to another war front where it is required, right? Thus the ratio 100 by 0 is meaningless and it cannot represent a rational number. Conversely, if there is no provision and the soldiers are still alive, it would mean 0 by 24. With no food, the soldiers will anyway die in a few days out of hunger. So there will be no food and no soldiers. Hence the ratio 0 by 24 will be 0. Thus 0 by 24 is still a ratio and it can be called a rational number. From this rather somber scenario, let us define rational numbers. Rational numbers are all those numbers which can be expressed as a fraction p divided by q, where p and q are both integers, but q is not equal to 0. The set of rational numbers is denoted by capital Q. Examples of rational numbers are 3 by 4, 5 by 20, 3, -7, 1 million, a fifth, -3 by 5, 52 by -13, and so on. Note that -7 can be written as -7 by 1, or 1 million can be written as 1,000,000 divided by 1, and a fifth is 1 by 5. Hence, they are rational numbers. Also, since rational numbers are basically ratio of two integers, the integers can be negative or positive. Hence, 52 by -13 and -3 by 5 are all rational numbers. Let us see how we can represent rational numbers on a number line. We have seen how to represent integers in a number line, right? For example, 3, 4, 5, 6, and 7 as shown here. Suppose we magnify the gap between two integers, say 4 and 5, in the number line, and further divide it into 10 equal parts. How do we measure and name them? We can do that with the help of rational numbers as fractions. Note that one unit got divided into 10 parts, so each part is 1 by 10. Hence, we can name them as 1 by 10, 2 by 10, 3 by 10, and so on in our magnified line. The measure of 1 by 10 and 2 by 10 from the left in the original number line is 4 and 1/10, that is 41 by 10, and 4 and 2/10, that is 42 by 10 respectively. Hence, the other measures are 4, 3 by 10, 4 and 4 by 10, and so on until we reach 5, which is the other end of the magnified number line. What if we divided the gap between 4 and 5 into 5 equal parts? Then each part would be a 1/5, right? Hence the measure from left will be 4 and 1/5, that is 21 by 5, and 4 and 2/5, that is 22 by 5. This will go on until 25 by 5, that is 5, isn't it? Note that 44 by 10 in the previous number line coincides with 22 by 5. Similarly, the pairs 46 by 10 and 23 by 5, 48 by 10 and 24 by 5. Thus, they measure the same quantity and hence are equal. This way, we can write the rational numbers in proper form, improper form, or mixed form. Remember, this is exactly how we follow the rules in case of fractions. Let us see another example. Suppose we have to find 7 rational numbers between -9 and -12. Note that both the integers are negative, that is, on the left-hand side of 0 on the number line. Hence, -12 placed on the left of -9. We have a gap of 3 units between -9 and -12. If we divide this gap by 7 equal units, each will be of 3 by 7 units, right? Hence, when we move from -9 leftwards, the first and the second points in the gap will measure -9 and 3/7, that is -66 by 7. And what about the points from second point onwards? Note that when we are moving left through every point, we are basically doing addition of each negative fraction. Hence, the points measure -3 by 7, then -3 by 7 plus -3 by 7, that is -6 by 7, and so on. This way, the rest of the points are -72 by 7, -75 by 7, and so on, until -84 by 7, which is nothing but -12. Suppose we have to find 10 rational numbers between -9 and -12. We simply divide the gap into 10 equal parts such that each part is 3/10. Hence, each point will be -9 and 3/10, that is -93 by 10, -9 and 3/10 plus another -3/10, that is -9 and 6/10, which is -96 by 10, and so on until we reach -120 by 10, that is -12. When we have both the number lines of the gaps from previous and present, we see that -93 by 10 lies on the right of -66 by 7. Hence, similar to integers, -93 by 10 is greater than -66 by 7. But -117 by 7 lies on the left of -99 by 10. Hence, -117 by 7 is less than -99 by 10. So, similar to fractions, we can also compare rational numbers by making their denominators same and comparing the numerators as individual integers. For example, when we compare the 3 rational numbers 5 by 6, -17 by 10, and 1, we first make the denominators same, which is 30 here. We get 25 by 30, -57 by 30, and 30 by 30. Considering the numerators as integers, we have the order -57 by 30 less than 25 by 30 less than 30 by 30, or -17 by 10 less than 5/6 less than 1. Can you represent this in the form of a number line? The hint is given here. That is all in this video for now. We will see how we can perform addition, subtraction, multiplication, and division in the next video. Stay tuned. Bye.